Okay, so in a prior video we have gone over the radical chlorination mechanism for chlorination of methane. And if you remember, first the chlorine radical must be furnished, and this usually requires an input of UV light or heat. This furnished chlorine radical abstracts a hydrogen from methane and furnishes the methyl radical in HCl. Then in propagation step 2, the methyl radical furnished in propagation step 1 reacts with diatomic chlorine to give you the chloromethane and the chlorine radical. And what you'll notice here, and this is very important, is that the radical used in propagation step 1, that's the chlorine radical, is furnished in propagation step 2. And the radical used in propagation step 2 is furnished in propagation step 1. And this is really imperative to the continuation of this radical chain mechanism. So if this radical is not furnished, then you cannot have chlorination again. Like you cannot have hydrogen abstraction by chlorine again unless this chlorine radical is actually furnished. So in this video, what we're going to actually be doing is looking at a mechanism that you probably have not seen before. Perhaps you have, but we're going to be radically chlorinating ethane, but instead of using Cl2, we're going to be using sulfonyl chloride, which is this compound here. And we're going to be chlorinating ethane using this compound, and you'll see that the idea of the radical being used in one propagation step, so this radical being used here being furnished in the other propagation step, that will hopefully be driven home by this video. Okay, so what we're going to be taking a look at is the reaction of ethane with sulfonyl chloride. And let's say you have heat or radiation, UV radiation, or H nu. So what happens? So you might look at this and be confused for a second if you haven't seen this before. But if you pause and think for a moment, you'll realize that this sulfonyl chloride is a source of Cl radical. And we're trying to radically halogenate, or radically chlorinate specifically, so we need Cl radical to be furnished. So how does that Cl radical get furnished? Well, you could have homolytic cleavage of this bond. And you'll get that Cl radical here, right? So this Cl radical, this is the initiation. So what does propagation step 1 look like? What does it look like? Well, this Cl radical is going to abstract a hydrogen, right? So this is ethane. It's going to abstract a hydrogen. Remember, you have to draw a half arrow. If you drew a full arrow, this would be a carbocation, and really methyl carbocations don't really exist. And that's a subject for another day. But yeah, remember that you have to draw half arrows when you're talking about radical halogenations because they involve radicals and not ions. They involve movement of single electrons as opposed to pairs of electrons. Okay, so here you'll have HCl formed as well as this ethyl radical. And propagation step 2. If you remember in the chlorination of methane, in propagation step 2, we had diatomic chlorine react with the methyl radical. Here there is no diatomic chlorine. Our source of chlorine radical was sulfonyl chloride. So that's what's going to be reacting with the ethyl radical in this case. I've drawn it like this, but understand that this unpaired electron is actually on the carbon, not the hydrogen. So you're going to get, it should be a half arrow here. Oh, so you will get homolytic cleavage here. Get the right color. Okay. And then half of this goes to the sulfur. And this way you'll form the chloroethane. And what you'll have left over here is this radical. But there's something you have to be aware of here, okay? This radical, the ethyl radical that's used in propagation step 2 is indeed furnished in propagation step 1. But this chlorine radical is not furnished in propagation step 2, but it's used in propagation step 1. So we need to furnish a chlorine radical. And the mechanism we've written so far does not accommodate for the furnishing of a chlorine radical. So how can we amend what we have here to furnish a chlorine radical? Well, the simplest answer is that this bond here can undergo homolytic cleavage. Or said another way, we can call this unimolecular decomposition of this compound here. So this one here, so we'll still have the chloroethane. That's not really used up in the reaction. But aside from that, we'll have this SO2 compound. This is like a sulfur double bonded to an oxygen. I'm kind of pressed for space here. And a chlorine radical. So here we do now have a chlorine radical furnished in propagation step 2, which can be used in propagation step 1. And that should really drive home that point that the radical furnished in one of the propagation steps is utilized as a reactant in the other. Now, something to be aware of, because this is chemistry and not something purely theoretical like mathematics, there are reactions that occur that you don't really want to occur. For example, because you have this chlorine radical furnished here and you have chloroethane sitting this mixture, there is nothing. So you have this chlorine radical here, right? And then you have this chloroethane sitting here. There is nothing stopping this chlorine from abstracting a hydrogen here and forming, say forming another another radical, but in this case a chloroethyl radical, which in turn, could react with this molecule here. So this could react with or I should say with this molecule here, because that's still sitting in the reaction mixture. So homolytic cleavage, and you could get a di-substituted product here. So CH2, or I should say, you'll have like a CH, and this will actually be attached to 2 chlorines and a CH3 group. So in effect, what's happened is another of these hydrogens has been substituted. So how do you avoid that? Well, you could use an excess of ethane. So this overall reaction here is a 1-to-1 stoichiometric ratio. Okay. But if you were to use an excess of ethane, what you'll have when you'll have ethane sitting here. Say you have a bunch of ethane sitting here, and you have this sulfonyl chloride here, but not as much of it. And the chlorination product is going to be this one chloroethane, right? But you'll have so much ethane sitting here that dye substitution, so this sulfonyl chloride reacting with a chloroethane is unlikely relative to it reacting with a regular ethane. So this is using an excess of alkane is one way to avoid polysubstitution products, because remember this is a radical chain mechanism. So this does continue, and the chlorine radical furnished in propagation step 2 can react with compounds that you don't want it to. So just keep that in mind. But the main point I wanted to make in this video is that, well, 2 points. One, that the radical used in one of the propagation steps must be furnished in the other propagation step. And the other is that if you have a compound like sulfonyl chloride that you're not used to seeing, just think about its role in the reaction. Knowing that you want to chlorinate ethane, you must think that, okay, well, we're going to have to somehow furnish a chlorine radical. How are we going to do that? Well, this bond can homolytically cleave, so you can have unimolecular decomposition of sulfonyl chloride to generate this chlorine radical, which can then function in radical halogenation of ethane. So those are the 2 points to keep in mind, and the last point was just, if you want to avoid polysubstitution products, use an excess of alkane reactant.